Evaluating limits of a piecewise function using graph. Our problem is construct the graph of the function fx is equal to x minus 1 when x is less than 0, fx is equal to 1 when x is equal to 0, fx is equal to x square when x is greater than 0. This is actually the domain. Okay, so suppose this value is 0, so it is divided into 3 parts. X is less than 0, another part is at the point x is equal to 0, another part is x is greater than 0. Okay, this is negative infinity and this one is positive infinity. So when x is less than 0, the function is x minus 1. If we know that x minus 1, that is y is equal to x minus 1. Okay, y is equal to x minus 1 is a straight line, isn't it? Since the equality sign does not hold at x is equal to 0 here, so for this a blank dot should be put here. So we put it here. So here slope is tan 45 degree, that is equal to 1. So makes 45 degree with the positive direction of x-axis, and it will not go in this direction because x is less than 0. This is the negative direction of x-axis and this is the positive direction of x-axis. For this, the graph is from this point to that way in this direction. Okay, so friends, the next part is the function fx is equal to 1 at the point x is equal to 0. That is, when x is equal to 0, function gets 1. So this is the point. This point is fx is equal to 1 at the point x is equal to 0. At the origin, the ordinate value is equal to 1. Mark it E. Okay, this is E, and this point is say B. Now fx is equal to x square. Fx is equal to x square. Actually, this is an equation of parabola. Y is equal to x square, like this, na? Y is equal to x square. So this is a parabola, and this parabola will be drawn in this way. But you see that the domain gives you restriction, some restriction. X is greater than 0. That is on the right side of the y-axis. That is, this is the positive parts of x-axis, positive values of x-axis. So you have to actually draw when the equality sign is not put here. So for this we have to put a blank dot at the origin. So the curve will be this way, this way. Okay, now next part is we have to find out limit x tends to 0 plus of fx. Limit x tends to 0 positive of fx. What is 0 positive? Actually, we have to proceed from right side of 0. This is 0. Okay, so when we proceed to 0 from the right side of 0, then at this moment we are actually proceeding on this graph, and the ordinate value will be equal to 0. So limit x tends to 0 positive of this function fx gets 0. And the second part gives you limit x tends to 0 minus of fx. Okay, that means we are proceeding to 0 from left side of 0. This sign, this negative sign is for the directional sign. So we proceed to 0 from left side of 0. Okay, closer and closer to 0. Then on this graph we are proceeding to actually more closer to minus 1. So the limiting value of fx when x tends to 0 minus is equal to minus 1. Okay, so friends, this is very important. Actually we are proceeding to 0 from right or left. When we are proceeding to from right side of 0, we are getting the limiting value 0. When we are proceeding to 0 from left side of 0, then the limiting value is minus 1. Since at the same point the right hand limit and the left hand limit are not same, for this the limit does not exist at the point x is equal to 0. Again I write here, LHL is not is equal to RHL, so limit does not exist at the given point 0. One thing I want to say, what is the value of the function fx at the point x is equal to 0? That means f of 0. F of 0 is equal to, you see that at the point x is equal to 0, the ordinate value is 1 unit. You may say that the ordinate value is 0. No, there is a open circle put, but the solid circle is here at the ordinate value y. So for this f0 is equal to 1. So we have studied from this graph the piecewise function, and we have studied the limiting conditions of the function at single point 0. Obviously you may take other values, other functions, so that you may be helpful from your concepts. And if you are helpful from these ideas, I think this will help in future also. Thank you. Have a nice day.